Let us discuss about a geostationary satellite. This is a satellite which appears stationary as seen from Earth's surface is called a geostationary satellite. Such satellites are basically used for direct communication of signals from one point in the zone of neighborhood of that point only. Like say if this is Earth and there is a satellite over here which is revolving in such a way that this satellite is always appeared to be located above the point X directly below the satellite. So when during rotation the satellite reaches this position, still due to rotation of Earth, point X also reaches a position such that satellite appear exactly above the point X again. So if someone is located on Earth's surface, always if the person is looking at geostationary satellite, it appears that always it is at rest with respect to that point on Earth's surface. Or from any point on Earth's surface, it can be seen that geostationary satellite is at relative rest. So when satellite broadcasts signal, the signal can be received on this zone of Earth, and we can say always the signal broadcasted from one point will be able to, these are able to be spreaded in the region neighborhood of that point from which these are spreaded. So such satellites are used for local communication in a specific country of a given geographic dimensions, or within the given geographic dimensions only such satellites can transfer signals. And in this situation, if we wish to find out the orbital speed of geostationary satellite, here we can say if Earth radius is RE and geostationary satellite is located at a height h above the Earth's surface. So here we can write the orbital speed of this geostationary satellite can be written as V is equals to root of g me over Re plus h. And if we wish to find out the time period of revolution, we can simply state for a geostationary satellite, its time period of revolution has to be equal to 24 hours, then only we can state that it appears always at rest with respect to a point on Earth, because as Earth revolves by one rotation, any point on Earth revolves by one revolution, geostationary satellite will also revolve by one revolution as it appears at rest with respect to that point on Earth's surface. And we know that satellite period is calculated by t is equals to 2 pi over root of gme multiplied by 3 by 2 power of the orbital radii. Here it is Re plus h, so it can be written as Re plus h to power 3 by 2. So in this situation on calculation we can write t square is equals to 4 pi square by gme Re plus h to power 3, which is also the relation directly can be used from Kepler's third law. And in this situation, if we further simplify, the height of geostationary satellite above the Earth's surface can be written as, in this situation we can also write gme over Re square as gs, that is acceleration due to gravity on Earth's surface. If we substitute on simplifying, we will be getting h is equals to gs Re square t square divided by 4 pi square to whole power 1 by 3 minus Re. On simplifying, the value of h is approximately 35950, or it is approximately 36 into 10 to power 3 kilometer that can be used. Now in this situation, we can see a realistic situation over here. Here if you just have a look on the situation, this is Earth, and in the surrounding of Earth at this height h, if we consider an orbit and if there is a satellite in this orbit, you can see this satellite is revolving around the Earth exactly with a period of 24 hours. But for this, the orbit must be in the equatorial plane of Earth. As we can see here, in this view, you can see that the satellite is revolving right above the equator in the plane which we term as equatorial plane, and the orbit of satellite in this situation is called parking orbit, because at every point on Earth's surface, if we just have a look on the satellite, it appears to be at rest because it is always located exactly above a point on Earth's surface. So for geostationary satellite, you can always write this important note that parking orbit, which we generally term as the orbit of a geostationary satellite, it must be in equatorial plane of Earth. And this is necessary because if this Earth and about its own axis of rotation, Earth is revolving at the angular speed omega e, which can be written as 2 pi by 86400 radian per second, as we write angular speed as 2 pi by t, and 86400 are number of seconds in a day, so it is the period of rotation of Earth in seconds. In this situation, any point on Earth's surface will be revolving in the largest circle over the Earth. And if we consider an orbit for geostationary satellite in the plane of equator, we can call this as parking orbit, which we have discussed in the previous slide also, in which if there is a satellite, this is a geostationary satellite, which always appear exactly above the point x on Earth's surface. Because if we consider any other orbit, like say this is the orbit we consider of same radius or same height as that of geostationary satellite, in this orbit also the time period of satellite will be 24 hours, but it will not appear to be at rest. The reason is if there is a point which is vertically above a point with respect to a location on equator or anywhere else, then after some time due to rotation of Earth, this point will reach here and this point will reach here. So exactly it will be inclined later on, and we can state that in any other orbit which is inclined to equatorial plane, even if the satellite is having orbital period of 24 hours, it will not appear to be at rest with respect to a point on Earth's surface. So we can state for geostationary satellite, the orbit must be in equatorial plane, then only it is possible. Otherwise, the geostationary satellite will not appear to be at rest, or if the orbit is inclined, the satellite won't be termed as a geostationary satellite.